Hi, welcome you all for the fundamentals of embedded system. In this video, we are going to see about bitwise operator and how bitwise operators are used in embedded system, and then we will see bit manipulations. So why we are going for bitwise operator? So by using bitwise operator, we can individually set a bit of a data. If you take any data, in that data, if I want to set particular bit or I want to handle a particular bit out of the data, that can be done using the bitwise operator. By using this bitwise operator, we can able to control the hardwares of the embedded system. These are the common operators which we generally use in normal C itself. This is used for AND operation, and this is used for OR operation, and this symbol is used for XOR operation, and till symbol will be used for NOT operation, and this is for left shift and this is for right shift. Next we can have a simple program using bitwise operator. Here I have taken a simple example in that I have taken two integer value a equal to 5 and b equal to 3. Then I am going to do AND operation between a and b. Before going to the AND operation, we can have a truth table. In AND operation, if both my inputs are 1, then my output will be 1. And what are the remaining possibilities? I can have any one input as 0 and another as 1. Here this is 1 and another as 0, or else both the cases can be 0. So out of these three possibilities, exactly the output will be the 0, because AND operation is nothing but if both my inputs are 1, then only I can obtain the output as 1. In remaining cases, the output will be 0. Okay, here I have given a binary value for 5 and this is the binary value of 3. I am going to take the binary value of 5 and 4, 5 and 3. Then we are going to do AND operation. If both are 1, then the output will be 1. Any one of the input is 0, then obviously the output will be 0. So this is the result that we get after doing AND operation of A and B. And what is this binary value into decimal? The value is 1. This is a simple example of bitwise operator, how the bitwise operation is happened. Here I have taken the example for AND operation. Similarly, we can try OR operation, XOR operation, left shift, everything we can try by using the bitwise operator. Okay, why bitwise operators are very much important in embedded system? Because by using the bitwise operator, we can control the hardware registers. Mostly, if you go for embedded system, the register will consist of 8-bit or 16-bit registers. Out of the 8-bit, each bit will handle particular work. Like if I want to toggle an LED, that particular LED will be connected to the second bit of the register. If I handling that second bit, I can able to control my LED. Similarly, all the hardware registers control can be done by using the bitwise operator. Like I want to make the bit as 0 or I want to make the bit as 1, everything can be done using bitwise operator. As well as by using the bitwise operator, they are saying that it is efficient data manipulation. It performs the efficient data manipulation. Also, memory usage is low when compared to some other methods. Some examples are, if I want to, like so as I mentioned, right, in microcontroller I want to control an LED, like I want to turn on and turn off. Particularly if I toggling the, like if I change the particular bit of the data, I can able to control my LED. Bit manipulation in embedded system. In embedded system, like we often use it to control an individual bit of the hardware register. What are the common operations that we generally perform in embedded systems are setting a bit or clearing a bit or toggling a bit. By doing this operation, I can control my LED, sensor and motors. Now we can go one by one, like how to set a bit, how to clear a bit, then we can see how to toggle a bit. First we can see bit set operation. Bit set operation is nothing but I want to set my particular bit as 1. For example, my bit is 0, but I want to particularly change that bit alone as 1. That's called as bit set. Here I have taken an example, a equal to 0001010. Generally, if you take this binary value, the bit count will be start from 0. This bit is 0 and this is a 8-bit 8-bit register. So the bit starts from 0 means what is the last bit? This is 7th bit. So if I take a 8-bit, it starts from bit 0 to bit 7. If I take 16-bit, it starts from 0 to bit 15. In this input, I want to set bit 2. Bit 2 is nothing. This is 0th bit, first bit and second bit. I want to set this bit. Currently this bit is 0. We are supposed to change the bit as 1. Okay. In order to change this bit as 1, we are doing some operation. Like I'm creating a mask. Creating a mask is nothing but I want to make change to my bit 2. So I'm keeping bit 2 as 1 and all remaining bits remains as 0. This is the thing which I have created. How I have created a mask? For an example, let me take the value 1. I'm going to do left shift of 1 in the sense this 1 will be moved from bit 0 to bit 1. So what we will obtain? We will obtain 1 0 after one time of left shift. Again I am going to do the one more left shift. Now from bit 0 to it will move to bit 2. Okay, now the value will be 1 0 0. So what I have done, I have taken 1 and then I have left shifted twice. So if you see here I am getting the same value. I have kept remaining previous bits at 0 0 0. So how I can explain this mask means one left shift of 2, which is nothing but my mask value. One left shift of that is I have taken 1 and do the 2 times of left shift, then we can obtain this mask. So this part is clear, right? One left shift of 2 is nothing but this value, mask value. Then they have taken a value and between a and the mask value they are doing the OR operation. So I have taken this is my a value. Okay, this is my a value and this is nothing but my mask value, and I am performing OR operation between a value and my mask value. OR operation in the sense if both the inputs are 1 or any one inputs are 1, then what will be the output? The output will be 1. If both the inputs are 0, then only the output will be 0. This is the general truth table of OR gate. We are going to perform OR operation. Both are 0, so the output is 0. One of the input is 1, so the output is 1. One of the input is 1, so the output is 1. One of the input is 1, so the output is 1. In remaining cases, all the 2 inputs are 0, so it remains 0. Can you observe? This is my input and this is my output. What was our motive? We want to set the second bit. Look at this. Here the second bit is 0. After doing some process, the second bit is 1. So by using this formula, we can able to set particular bit. Which bit I want to set? That particular bit can be set using this formula. Second bit means left shift of 2. Third bit means left shift of 3. Okay, in programming we generally use this formula. We are not going to in depth and understand what is happening, but if you are using this formula, you must have some idea why this formula is used and what is happening behind this formula. That's what I have explained using some examples. I hope now bit set is clear, right? Next we can go with bit clear. Bit clear in the sense previously I want to change my bit 0. If it is bit, I want to make it as 1. That is bit set. Bit clear is nothing but now my value will be 1. I am supposed to change the particular bit as I want to clear that bit. Make it as 0. This is called bit clear. Okay, this process is called bit clear. Similar like previous one, I have taken a value. And in this value, I am going to clear my second bit. Second bit is nothing but this is my second bit. And I have created a mask. One left shift of 2. Because 1 is here, 2 times left shift, my 1 will come here. Okay, this is my mask. After I have created a mask, then I am taking not. Not is nothing but whatever value is 0, that will be inverted as 1. If the value is 1, that will be changed as 0. After doing the NOT operation, this is how my mask will look like. So what we have done? We have left shifted 1 left shifted twice, and then I have do NOT operation. NOT operation is nothing but this tilt symbol. So by doing this process, we obtain this mask. Okay, after doing this process we obtain this mask. Then what they are doing? They are doing AND operation with a value. So this is my a value and this is my mask value. Okay, I am doing AND operation. Okay, this AND operation is done here. You know what will happen when we are doing AND operation. What happen if the both the inputs are 1, then only we obtain the value as 1. In all the remaining case, like if both are 0 or any one input is 0, what will be the output? Any one input is 0, the output will be 0. So this is the truth table of AND. We can see 0 and 1. If I do 0 and 1 AND means output will be 0. If both the inputs are 1, then we get 1. Here 1 is 1 and another input is 0, so the value is 0. Here both the inputs are 1, so the value is 1. In all the remaining cases, one input is 1 and other input is 0. So 0, 0, 0. Now we can compare. This is our input, okay, and this is our output. What was our motive? What was our motive? We are supposed to clear the second bit. This is my second bit. My second bit is 1. See here, we have cleared the second bit. This is happening behind this formula. In programming, we usually use this formula only, but behind the formula, this is the thing happening. Okay, now you are clear about how to set a bit as well as how to clear a bit. Set a bit is nothing but changing the value 0 to 1. Clear a bit is nothing but changing the value from 1 to 0. Next we are going to see bit toggling. Bit toggling is nothing but irrespective of the bit state. It may be 0 or 1. If it is 0, it is supposed to change as 1. If it is 1, it should becomes 0. Okay, whatever might be the input condition, like it may be 0 or 1, but if it is 0, we have to change it as 1. If it is 1, we have to change it as 0. This is the thing we are going to do in bit toggling. Okay, similar like bit set and bit clear, we are taking one example a value. Then in this bit toggle, I want to toggle my first bit. What is the first bit? This is my first bit. If I want to handle the first bit means we are going to create a mask. Here the first bit. So what I am supposed to do? I have to left shift 1 by one time. One time is enough because I am going to toggle my first bit. Okay, this is what done here. One left shift of 1. So here I have 1. Next what they are doing? They are doing XOR operation between the A value. Okay, between the A value and between the mask value. Between A and the mask value, they are performing XOR operation. What does mean by XOR operation? If one input is 1 and another input is 0, then the output will be 1. If both my inputs are 1 or both my inputs are 0, then the output will be 0. This is the truth table of XOR. Now we can perform XOR between A and our mask value. Both are 0, what will be the value? 0. Both are 1, value will be 0. Both are 0, 0. Any one of the input is 1 and another is 0 means then we can obtain the output as 1. So here we have obtained 1. This is the value we obtain after performing XOR operation between A and our mask value. Look at the input. What was our motive? We are supposed to supposed to toggle the first bit. Here my first bit is 1. After performing some operation, my first bit is changed as 1 to 0. Okay, this is how we are toggling the bit. Now you can take this as input and toggle the first bit and check whether you are obtaining this one. Okay, because I'm just toggling this one, right? If I toggle the first bit, obviously we must obtain this output. You just try and check whether this formula is working. As mentioned earlier, this is the formula we will use, but backend what is happening. That's what I explained here. Okay, I hope now you are clear about bit manipulation like bit set, bit toggle and bit clear. Hope you understand the topic. That's all about today's topic. We can meet on the next topic. Thank you.